Hello and welcome back to this tutorial on learning Julia. We've programmed a card game, and the idea is that we have two different agents playing this card game against each other, and we want to now see which strategy of these works best. And one of the things that we've been doing so far, we've created this long program. It's 134 lines of code. Obviously there are some comments in there, but what we call this in software engineering is we've created a monolith. It's one large program that is basically, you have to follow it from start to bottom. And that's a little hard to comprehend if you're not familiar with the code. So one thing that we do is we try to wrap functionality in a function. And the idea of these functions is that they will help us set up a program that we can run parts of them easily one after another. So let's get a better understanding of where we are. So we have this player 1, we have this player 2, we have this game has ended flag, we have 2 players, we have the car structure that has all kinds of features, and here basically we create a set of cards. And what this does, it returns this all cards vector. And one thing that I think makes sense here is to maybe wrap this in a function, and then you will see why a function is a benefit. So what we'll do is we call the function keyword, and the function keyword will say load cards, and it doesn't get any parameters, and it just does nothing. And what we want to do is we want to create all of this, and maybe even this error, this message here. So we put all of this in here, and since it's a function, we want to indent this one step. So the idea is if we now run load cards, it does everything that we've written inside of this function. And the idea is that we return this all cards vector here. So we do return all cards, and then outside of here we can get the content. So since Julia is not active, let's start from the top. We run all the things here. We load the car. We initialize this function load cards, and we see this as a return. Now there's the generic function with one method. And there's a difference between functions and methods. Every function with the same load cards is a method, and we can have multiple versions of load cards, and we only have one method of it. And that one is generic because it accepts all parameters, in this case none, but they are of all possible types, none of them are. So what we can now do is we can call this function load cards, and just by calling this simple line, we can now generate a vector of cards, and we can do a second deck, and then we would have a second deck of cards. To make this a little more understandable, I would change something in here, and that is I will let's say load deck. Maybe that's a better name, because that's the deck of cards that we have. And move this down here. So now we call load deck. So if I run this, I can now, I get all deck. In this case, all cards is the deck that we're using. So I would, inside of this function, I would rename this, and there is a feature in the editor to rename everything inside of the current scope. And that is, I think with right click, I can do share. Is there a rename symbol? And I will call this deck. And it automatically detects that inside of this function, everywhere where it said all cards, it replaces it with deck. And the load deck function now returns the content of deck, and that is stored in all cards. So the rest of the code is not affected by this. It will basically just say all cards will contain the same thing as load deck had. So if I do this, I still have everything that I need in my all cards variable, and you will see this is the vector. And we could now have multiple functions of load_dict. We could have a function that, for example, takes this data from a CSV file, and we can generate a CSV file and then add that content in there. And for this purpose, I think it makes sense that we load our first library. Have we been loading libraries? I'm not so sure. No, we have not been loading libraries. We've been running completely without different packages. And to give you a better understanding of how this works, we go into the Julia REPL and we enter a closing bracket. And this gets us into the package manager. You see here, I'm running version 1.9, and now I can do stuff like status, and this tells me where I am. I am in the Julia environments version 1.9 project TOML, and this is an empty project. So if I add a library here, it will add it to my base Julia environment, and that is something I don't want. So one thing that I can do is I can do activate dot, and this will now activate the current project. It's called session 2 because we're in the folder session 2. And if I now add a library such as CSV, it will add a library to this project that I'm working on, and it downloads a registry, and it gets all kinds of information about the compatible versions, and it creates two files for us. One is the manifest TOML and the other is the project TOML. The project TOML it contains the information, which packages have we installed. In this case, no, we don't want a TOML reader. In this case, the CSV file, the CSV package, and it gives us a hash, which is a version string for this package. You don't have to understand this. It just tells you that we have CSV. The manifest TOML, on the other hand, it contains all the subdependencies of this project, which allows someone else to recreate this project. So if you want to recreate this project, if someone gives you the manifest TOML and the project TOML and the main JL, one thing you could do is by going in this package manager mode and typing in the question mark, it will give you all commands in here. Activate sets the active package the active environment, and you could do instantiate, and this will download all the dependencies. So even if I only share these TOML files and the JL file with you, you can regenerate this project by calling instantiate in here. So if I do instantiate, it will do nothing because I already have them installed. But this is something that is kept locally, and if I share only these files, you will not have the libraries. But if you call the instantiate function, then you will have the libraries. If you are running inside of a local environment such as this session 2, it makes sense to make sure that the local environment is always loaded. And we can achieve this by using pkg, which is the package manager, and then calling pkg activate dot. This will ensure that whenever you run this file, that you're activating the current project directory. Now we have the CSV file, and one thing we can do is we can try to write the CSV file. CSV dot write. Wait, let's call using CSV. Now we have the library loaded, and now we can do CSV dot write. And this will, if I just execute it like this, it will return an error. It says no method matching write because this is the wrong signature. I have to give it a parameter. The write function requires that I tell it what to write. And this is a good exercise in trying to understand Julia error messages. So it says no method matching, and the closest candidates are write table schema. So there's something where I have a table schema, or nothing, any, or any and some keyword arguments. So I can basically just add something to it. So let's try all cards, because that's of the any type. Let's see what happens. It returns 101, and so that actually returns a generic function. Interesting. Let's see what this does. I just do F, and if I now call F, what happens? that doesn't work. So maybe that's not the right way to do this. Let's have a look at how this works. For this, I will look up the CSV package documentation for write. And one way to have a look at it is by typing the question mark and typing in csv.write, and this will give me a documentation, which is not the easiest to read, but it will give sufficient information that we can understand what we need to do. It write a tables.jl interface input to a CSV file given an IO argument to string file paths. There are a lot of other keywords. So an example would be, we have a data frame CSV write and the name and the data frame. So another thing that we need is the data frame to write these things down. Write a matrix to an in-memory IO buffer. Okay, the best way I think is to try the data frames package as well. So one thing we should do is using data frames. And now it will say, if I execute this, error, argument error, package data frames not found in current path. We have not installed the library data frames, which we need to do by going closing bracket, add data frames, and this will add the library data frames for us. And what you see here is, by the way, it's trying to understand the dependencies of data frames, and it loads crayons, data structures, formatting, and all these other packages. And it gives you a progress bar and telling you how far it is. This can take a while depending on how many dependencies the package has that you're installing, but data frames is relatively fast, and I have a fast internet connection as well, so it's not too much of a problem. And after downloading all these packages, it pre-compiles them so that they can run on my machine. And this is what takes a little bit longer because it has to install, it has to compile all the dependencies as well. Okay, we have data frames, and the way it works is we give it a file name, our cars.csv, CSV, and we need to give it a data frame. So we just say car.df, but we don't have this car.df yet. So what we need to do is we need to change these cars into a data frame. How do we do this? So let's have a look at the data frame data type. What is a data frame? Can we create one? No, we cannot. Let's have a look at data frames. So I go into help mode by pressing question mark, data frames. Binding data frames doesn't, perhaps you meant data type. Okay, we don't see this, so we go into Google and look for the data frames package. That's not a very helpful command, so I have to type in Julia as well. Introduction data frames. So data wrangling, no. What is data frames? Getting started. So we have to add the package data frames, which we have. And we can create a data frame by giving its names and then variables. So, okay, let's try this. Let's do a car.df is a data frame, and we'll have car name is, and where's my cursor again? Car name is test. If I do this, data frame not defined, because I didn't load the data frames. Oh yeah, I didn't load the data frames. So this creates a 1-by-1 data frame. It has one column that is named car name, and the first entry is called test. So what we need to do is, let's have a look. Let's make this a little bit smaller. Where is our car? It has a name. It has a top speed. The top speed is a number. Let's say it's 200. LPK is a float as well. That's liters per 100 kilometers, I guess. Let's say 8. Horsepower, let's say 150. range, let's say 550, weight, let's say 800, cylinders, let's say 8. So this creates a single, let's make this bigger again, a single data frame entry in our CarDF, and now I should be able to write this file. And it creates this CSV file, and the CSV file, the way that this is structured, let's not do this. It tells me these are the variable names: car name, top speed, LPK, HP, range, weight, cylinders, and this is the entry. And if you recognize these numbers, it's because what we call our Mustang. So let's call this Mustang, and this would be our first car. So obviously we don't want to create these individually. We want to, maybe let's copy these data over. And by the way, if you just copy it like this, this is the same order as the variables. And in this case, we have them in quotation marks, and that's not a problem because you can have strings in a data frame in quotation marks. And let's see what happens if we just copied these variables. Let's see what happens if we load these variables. So let's do our df as our data frame, and we do the opposite, which is csv.read, and let's read our cars CSV. Provide a valid sync argument using data frame CSV. Oh, okay. CSV read, and I think we have to tell it how to store this, and we tell it to create a data frame from it. We could also have a table or a matrix or whatever, because a CSV file can be interpreted as many things. And in this case, it's supposed to be a data frame. Let's run it again and see what happens. Yeah, it creates a data frame that contains the cars that we have, a Mustang with 200 top speed and so on. So what we can potentially do with this is we can have a set of cars in a CSV file, which can then be used in our main program, instead of having to define it inside of the program. So loading the deck as it is kind of, we have to manually write these things in here. But what we would rather want is we would want to have them in a CSV file. So what we learn now is how we can take the data from this data frame and generate cars from it. So let's put these two things on top, because we want to load the libraries early in the beginning. And what else do we want? I think we can now remove all of this, because these are inside our cars, and we need to somehow get a car from each line of this data frame. So this we still need. It's calling this load deck. This we no longer need. This is just writing a data frame, and we've just created one, so we don't need this anymore. This we also don't need anymore because we've already written this. So now it's only the question of how can we read the data frame. And let's put this up here. And in the load deck function, now this will load a data frame. And obviously if I call this, the all cars now only has one car in it, because it only has this Mustang in here. From this data frame, we don't use it in our deck. So we have to create cars from the individual CSV lines. So we have this data frame, and we need to get from the data frame into the cars. And let's test this outside of this function, because calling this inside of a function is a little bit tricky. So we'll put this here to test how this works. So our df, and we want to go through this data. So the data frame has 4 lines, and for every line we want to create a car. And how would we do this? Let's see what is length of our df. Length, we should probably spell this right. Length, there is no method. So let's call nrow, which is often we have 4 rows. So number of rows is this what this means. So for every row we want to create a car. So for r in 1 to n row, so for every, let's print r, and this will give us the numbers 1, 2, 3, 4. Okay, so this helps us read all, or at least have the numbers for all the individual rows. What we can now do with the data frame is, so this just gives me the data frame, but if I put in brackets, I can now say something like 1, 1, and this will give me the first column and the first row entry, which is the Mustang. So let's see what happens if I do 1, 2. This gives me 200. So the first parameter in here is the line. So let's do R and do 1. And if we print this and we do print line, we should now see the name of all our cars. Mustang, Mini Cooper, yeah, perfect. So going through the individual lines, that makes sense counting it, but 1 is kind of like, we do have a name here. It says car name, right? So what happens if we do car name? And what happens? It does the exact same thing. So we can access the individual named columns by putting a colon and then the name of the variable in here. So how can we generate a car from this? So a car needs a car name. Let's remove the print. And this is the car name. So getting to the data frame and then the car name. The next thing we need is not the car name, but what are the variables? The top speed. So let's do top speed. And we should probably put this like this so we can see what's going on. Oops. And after the top speed is the LPK. After the LPK, we have HP, range, and weight. HP, range, weight. And I think the last thing is cylinders. So if we do this, we should generate 4 cars. Obviously this doesn't, wait, top speed not found in the data frame, existing most similar name are top seed. Oh, okay, we did the same thing here again by writing top seed. We can change this by changing it in the data file because the data frame is created from the data file. So if I read this in, I now get a new name and this should work. It now creates 4 cars and does nothing with them. The cars are not stored anywhere. They're just created. We just get cars. And obviously we should push the cars inside of a data frame. So what we can do is we can move all of this, copy it in here. I don't need to push this anymore. I don't need to read the data frame anymore. And what we now do is, okay, we set up the empty deck, we read the data frame, and then we push the individual cars into the deck. And we do this for every row there is. So let's say this is called row car, and here we just assign row car to the car. So let's comment this a little bit. Read the data file into a data frame. For every line in the data file, create a car, and then add car to the deck. And at the end, print a message and return the deck. So what this function now, it's a little bit longer, but the function load deck, what it does now, it loads the cars from the our cars CSV, puts them into a deck, and then returns them so that the all cards deck now contains exactly these cars. And we can now add cars by adding new car descriptions into this data file. So I can do a Toyota. Let's not do a Prius because that's an electric car. I don't know car names. Let's just say Toyota. The top speed would be 180 liters per kilometer, 7 HP, horsepower maybe 130, range 680, weight 790, and 6 cylinders. So now we have 5 cars, and when I do the load deck function, it now returns a 5-element vector. And the idea now is that if you have this code, you can edit your own deck. Obviously, the names of the object have to be the same as we use them, because this is how we access them. And this is an important thing to note. Let's put it like this, so we have all the ones in each row. We access the data frame by going for the row line, and here we have a symbol that is named accordingly to the column names of the data frame. So if there's a different name so if I do something like top, I can just create the error again. And if I run the load deck function now, it says column name top speed not found. It's able to identify the names of the data set by using these symbols here. And this is a great way to make sure that your data matches, or at least describes or pretends to match the data that you want. And we can now add a 6th card so that if we have 2 players, it makes a little bit more sense. Let's have a look at there's a dataset called cars dataset, the Stanford cars dataset. And is there a car that I can just take? No, where is the car? Can I download this maybe? Cars test, 1.99 gigabytes. No, that's not what I wanted. I wanted the R cars dataset. Cars dataset. So is there one where you see a car? Okay, let's do the Chevrolet Chevelle Malibu. I don't know that car. And let's see what else we know about this car. It has 18 miles per gallon. I have no idea how to translate that. Let's make up some numbers. So top speed 250, LPK 12, HP 240, range 450, weight 1200, and 8 cylinders. So this is our 6th car, and now we should be able to have a 6 deck. Okay, so what have we learned? We have learned that we can write our own functions like this, and we can then easily call these functions. So if we want to repeat something, we can now very easily do this multiple times. Obviously, this doesn't change anything because they are all the same, but we can, wow, that looks ugly. Let's change this to capital letters here. We can call this function multiple times, and that is what we will need when we want to test the simulation that we're running multiple times. Another thing that we've learned is that we can access data sets like CSV files, and we can read them into a data frame, and we have learned how to interpret the data frame. In our case, we just read the individual column names into the car fields of the individual cars. Another thing that might be interesting to know is how to write documentation for your own function. And I think if I remember correctly, this is achieved by doing hash triple ticks? I'm not sure. Let's look it up. Julia function documentation. Writing comment documentation. So it is achieved by calling, oh, triple, okay. So by doing triple quotation marks, this is now the documentation for the load deck function. The easiest way to do is just to write a string. This function loads a deck from the ourcars.csv file. And this is now the documentation for load deck. So if I run this again, it should, if I hover it, it now shows me the documentation. This function loads a deck from the ourcars.csv file. We could give it a little bit more information. We could also tell it it returns a vector of car. Let's say vector of car. That's probably enough. And I think we can even, let's see, is there something how we can highlight code? It can have arguments that we don't need. Do we have something like defined return types? So there's even a documented JL thing that will help you create better documentation, but I think we're not going into more detail here unless there's something very soon about. Okay, we'll skip this for now. So what we now have is we have the load deck function, and it tells us how to use this function. I think by indenting it, it turns it into code. So maybe we'll just keep it like this. It returns a vector of car. Okay. Okay, the things that you should have taken from this session is how to create your own function. It's a function without arguments. We'll learn about arguments in the next session, and how to load data from a CSV file into a data frame, and how to then use the data from the data frame by accessing the individual rows and the individual columns using this type of notation. And in the next video, you'll see how we can use function writing to improve our simulation code and to help make sure that we can run the simulation multiple times.